In this video, we're going to look at how to transform graphs. We're going to start by looking at two very basic graphs that we're going to use and transform in a moment. And what we're going to refer to these graphs as our parent functions or our parent graph. So this is where we're always going to start. So we're going to look at kind of the most basic quadratic, which is x squared. So with most of the functions and equations we're going to work with, we can start by choosing our x values. So I'm going to use -2, -1, 0, 1, and 2 for x. So that way I have some positives and some negatives to see how this graph is going to look. So what I'm going to do is I'm going to plug each of those values in to the equation to get the y value. So in this case, y would be equal to -2 squared. Remember, when you're replacing, you're always going to put it in parentheses. So -2 times -2 is +4. And then I'm going to plug in -1, so y equals -1 squared. So -1 times -1 is +1. And then we'll plug in 0, so y is equal to 0 squared, which is 0. And then we'll plug in 1, y is equal to 1 squared, which is 1. And then we'll plug in 2, y is equal to 2 squared, which is 4. So now what I'm going to do is I'm going to take those points and I'm going to plot them on my graph. So my first ordered pair is at -2, 4. So to the left 2 and up 4. So right here, -2, 4. Then we have -1, 1 as our second point. And then 0, 0. And then 1, 1. And 2, 4. So you can see this kind of makes a U shape, which is called a parabola, and we'll talk about these graphs a lot more later. But there is our very basic x squared function. So you can see that I am eventually going to touch all x values since the graph will be moving out slowly to the left and the right. So the domain of this function will go from -infinity to infinity. But if I look at the y values, you can see that my graph kind of stops here and everything is up above. So this is a y value of 0. So my range starts at 0. My y values start at 0 and then they go to infinity. So now we're going to do the same thing, but this time with y equals the absolute value of x. So again, this is our parent function. I'm going to use those same x values I used before of -2, -1, 0, 1, and 2. And then we're going to plug each one in to figure out y. So y is equal to the absolute value of -2, which is 2. And then we'll do y is equal to the absolute value of -1, which is 1. And then we'll do y equals the absolute value of 0, which is 0. And then we have y equals the absolute value of 1, which is also 1. And then finally we have y equals the absolute value of 2, which is 2. And so now I'm going to take those 5 ordered pairs and I'm going to plot them on the coordinate plane. So we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So you can see that this makes more of a V shape, whereas the last one was a parabola and it made a U shape. But again, it's very clear to see that I'm eventually going to touch every single x value. So the domain of this function is also -infinity to infinity. But when we look at the range, you can see that we start here at a y value of 0, and all of our y values are above that. So our range is also from 0 to infinity. So now we're going to take those graphs that we just talked about, that we just looked at, and we're going to apply some transformations to them. And the first kind of transformation we're going to look at is a vertical shift. So this means the graph is going to shift up or down. So in this first one, we have y equals x squared minus 3. So our parent is y equals x squared. So we're going to take those same points from before, and we're going to plot them on our coordinate plane to start. So those points were -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So this is our parent graph. This is where we're starting, our most basic graph, before we do anything to it. And then what we've added to the equation is this -3. So what that means is the entire graph is going to move down 3 units. So we're going to take every single point that we just plotted and move each one down 3 units. So moving every single point down 3, here is our new graph. So we're still going to have a domain of -infinity to infinity. That's not going to change. But now with our range, you can see our graph starts here at y equals -3, and everything is above that. So our range will be from -3 to infinity. Now we'll look at our absolute value graph. So again, this is our parent function. And we'll go ahead and plot those points again. So those were -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So here was our parent graph, our starting point. And then what we've done to this equation is we've added a +2. So that means all of our points are going to move up 2. So I'm just going to take each point that I plotted and move each one up 2. So the shape of the graph is going to stay the same. It's literally just like I'm sliding the whole graph up 2 units. Once again, our domain will stay -infinity to infinity. And now, instead of starting at 0, our graph starts at y equals 2, and everything is above that. So our range is from 2 to infinity. Next, we're going to look at horizontal shifts. So that means the graph is either going to move to the left or to the right. So in this case, our parent function, if you notice here, we have this squared. Our parent function is x squared again. So we're going to start by plotting those x squared points of -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So here is our parent function again. Now this time we've added this -3, but notice that it's inside the parentheses with the x. That's how we know that it's a horizontal shift and not a vertical one. Now these horizontal shifts are going to kind of do the opposite of what we would think. So this is actually going to move our entire graph to the right 3. So we see the minus sign and we think it's going to move to the left, but it's actually going to move in the opposite direction. It's going to move to the right 3. So I'm just going to take all those points and move each one to the right 3. And then I'm going to connect them. You can see again my graph looks exactly the same. It's the same shape and the same size. It's literally just been shifted to the right 3 units. So again, domain is going to stay the same. It's going to stay -infinity to infinity. And you can see that both of my graphs start at y equals 0 and then they go up. So my range is the same as the original function. It's still 0 to infinity. So these horizontal shifts don't affect the range. And the next one, we can see with the absolute value sign that our parent function is going to be the absolute value of x. So we'll plot that. So -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So there's our V-shaped absolute value. And this time we have this +2, but again, notice it's inside the absolute value with the x. This is going to move everything to the left 2. Again, if it's a horizontal shift, it's going to do the opposite of what we might think given the sign. So I'm just going to take each of those points and move them to the left 2 units. So one of my points you'll see here is actually going to overlap. But again, nothing about the graph has changed. I've simply moved it to the left 2 units. My domain is still -infinity to infinity. And you can see that both of them start here at y equals 0 again. And everything's above 0. So our range is still 0 to infinity. Okay, so let's put those two transformations together. So in this first one, we can see that our parent function is absolute value of x. So let's go ahead and plot our absolute value graph first using those 5 points that we talked about at the very start, the ones that we keep using. So here is our parent function. Now this +2 is inside grouped with the x, so this is going to move everything to the left 2. And then this -1 on the outside, not grouped with the x, is going to move everything down 1. So I'm going to take all of these points, I'm going to move them, and I can do this in one step, to the left 2 and down 1. And so here is my new graph. Again, shape is the same, size is the same. It's just everything has been shifted to the left 2 and down 1. So that means my domain is still just going to be -infinity to infinity. But now my y values here start at y equals -1 and everything is above that. So my range will be from -1 to infinity. For the second one, we can see that our parent function is x squared. So we'll go ahead and we'll start by plotting x squared. So same points that we keep using over and over again. So here's our parabola. Just going to label this our parent function. And then this transformation inside the parentheses grouped with the x, this -1 is going to move everything to the right 1. And then this +2 not grouped with the x is going to shift the graph up 2 units. So I'm going to take all of those points on my graph, I'm going to move them to the right 1 and up 2. And so here is my new parabola. Once again, my domain is not going to be affected. It's still going to be -infinity to infinity. And then for my range, you can see now my graph, the lowest y value is y equals 2, and everything is above that. So my range is from 2 up to infinity.